So I will do a very quick introduction to our chemical naming tools. You already saw some use case inside ChemCurator. And so let's see if this works. Yes. So this is a recap of the tools that we have at ChemAxon. We have a tool for converting the chemical structures to IUPAC names, so that's the structure to name conversion. And that hasn't been mentioned yet, but what has been mentioned in the previous talk is all those that do the other way around. So starting from the names, getting the structure, so that's name to structure. And then if you do this not on a specific name, but on a full document, then that's document to structure, which is the API for that. And finally, document annotator, which is when you actually output a new document with the annotations on it. So what I will present to you today quickly is a few handpicks improvements that have been happening in the last year, among others. I will focus on name to structure this year. And last year it was structure to name, so just to keep things varied. Then I will mention the architecture, which typically used by various customers and integrators, and also inside ChemAxon. The whole workflow, or how the architecture works when you want to build a system that does custom document processing, going from documents unstructured to structured data that you can use. And then I will give the floor to Aurélie from Questel, who will mention how they did that at our partner project with Questel. So this is a few examples of the things that have been improving in name to structure, and this is basically a focus on the fused rings, which is one of the, maybe some of you studied this, one of the more complicated parts of IUPAC nomenclature. So here you see some examples. On the left you have multiple first order and higher order components in a fusion. So basically you have a main ring, it's at the right, it's the phenazine. And then so you have several fusions, like fusion on something else. So that's something that wasn't supported until now, and now it is. So more coverage. And on the right side, this is a different case where there is a single fusion, but the geometry of the structure is relatively complex in that finding out which atom is number one, that's something that's not completely obvious. And maybe if you had to do it by hand, I don't know how many people would, that anybody who thinks they could do that knows the rules for that. So basically now we implemented that, so hopefully you can trust the software to do it. Before, because it didn't know, it would ignore it, so it would not try to make a mistake, but now it knows that. So that's an example of the improvements we make year after year. Now to focus on this workflow of processing documents, so I mentioned document to structure, so this is our API that detects and extracts the chemical structures from documents. And so you can process a whole document, but you can also, in your integration, you might want to process sentence by sentence, or maybe one paragraph, so you have a choice of the granularity. And there are a lot of options because, as you can imagine, depending on the use case, you might want only complete structures, or you might also want the fragments, or you might want the chemical elements or not. So, and there are really tens of them. So that hopefully you can find the ones that would be the most relevant for you, or if you build something for your end users, you can also give them the option if you think that's relevant. And if something is missing, or if you're not sure how to use that, then please contact me. And this document structure is something that's used by quite a few integrators now, but it's also used by ChemAxon products. So if you are looking into something like this, you have seen a presentation on ChemCurator, and you will see ChemLocator very soon. Document annotator, so I just give a screenshot here. This is what can be the output of it. So basically at the input you had a PDF file, in this case from a patent. And what you see here is the annotated version of that. So you have the IUPAC names that are, so everything that's in gray has been annotated. So the IUPAC names, and also the images, in this case using image to structure tool. And so the output is HTML, and that's something you can use in web tools or other tools. And so the input is a document in basically any format that's relevant. and the output is HTML. And because this is an API, as most of our APIs at ChemAxon, you can use it either from Java or .NET platforms. And that's how you can integrate with your custom applications. And so now if we look at the big picture, what can you do if you want to build a system to find chemistry in documents? So basically at the starting point will be on the upper left, the documents. And then one way to do it is in two directions. So down you use document annotator to generate annotated versions of your documents in HTML, and you can store those. You could also do it on the fly. As you want to show a specific document, you generate the HTML version. And on the other part of the workflow is that you use document-to-structure to generate a list of structures for every document. Again, you could do it in batch once for all your documents, or you could do it on the fly. That depends on your use case. And then once you have the list of structures, you will use our database engine, JChem, for storing those structures in the database. And once you have the database, using, for instance, something like Maven.js, you can build a query, use JChem to query a database, and get the results that you will display. So that's the basic idea that quite a few people have used now to build such system. And so now what I will give the floor to Aurélie from Questel, who will show how they did that at Questel. Thank you.
Yeah, we know that UPAC tends to change the rules from time to time, and I was just curious, how strong does this impact your work or your development of the name to structure or structure to name interface?
Yes, so actually there was from time to time, it's relatively rare. It's like a big event when there is a new version of, at least for the organic chemistry, there was a new version in 2013. And I think I was quite lucky because just when I started to work on this, it was, I think, 2005 or 6. And they had just released the draft version of what, like almost 10 years later, became the official version of IUPAC. So basically, especially for structure to name, from the start, I could have a good idea about what is going to be the next version, and it made sense to focus on that. Actually, for name to structure, obviously we want to support the newest version, but we also want to support whatever has been done 10 or 50 or 100 years ago, because all the patents and all the literature has been written over the years. So obviously we use the latest 2013 version as the kind of the gold, but we also look also what was the standard before, but also everything that chemists have been doing, whether it's really the rules or not bending a little bit the rules. That's also what we try to support.